Kirchhoff's voltage law. The algebraic sum of all the voltages around a loop is zero at every instant. So we will talk about what that means. Now let's use this circuit to check KVL, Kirchhoff's voltage law. In this circuit, we have four components. We have a voltage source, 7 volts, and we have 3 resistors, 1k ohm, 2k ohm, and 4k ohm. Each component, I connected it with a digital multimeter to check its voltage. Let's run the circuits to see what will happen. By the way, this is the multi-sim simulation. Okay, let's run it. Now you can see, when I run it, I click this digital multimeter, and if we select voltage, we will see it shows this voltage source is 7 volt voltage source. Now I click this one, you will see 1 volts, 2 volts, 4 volts over here. Now what is Kirchhoff's voltage law? That is talk about the total voltage around a loop is equal to 0. Now you can see from here to here 1 volt drop, from here to here 2 volts drop, from here to here 4 volt drop. And then here, if you start the loop from here back to here, you will see this is from negative to positive. Actually, it is a voltage increase. And this voltage increase is 7 volts. So dropped 1 volt, 2 volts, 4 volts, increased 7 volts. Altogether, the total voltage drop is 0. Let's look at this KVL exercise. In this circuit, their question is, they want to know the voltage across the 5k ohm resistor, this one. So what we know is, we know the 3 volts, 2 volts across 3k ohm and 2k ohm, and the power supply is 10 volts. So how to get the voltage across this 5k ohm? Let's use the KVL. KVL, we can consider a loop. This loop, we can go clockwise. And then we can, since it is a loop, actually you can start from anywhere you want. For example, I will start from here. So the voltage drop, because I'm counting all the voltage drop, the voltage drop on this 3k ohm resistor is 3 volts. So that's why you have 3 here, and then the drop here is 2 volts. The drop here, I use the question mark to represent it. And then when you go back to here, from here you can see from this node to this node is actually increased 10 volts. So you actually put a negative sign here. So this is a trick. There's a trick over here. Whenever you see the polarity, the positive sign, when you see the positive sign of the polarity, you put a positive sign. So positive 3, positive 2, positive question mark. And then when the loop goes through the negative sign first, you put a negative sign, like here. Then we just need to solve this equation, find the question mark equal to 5 volts. So that means across 5k ohm resistor, the voltage is 5 volts. Now let's look at another exercise. In this exercise, some variables are known already. So V1 5 volts, V3 negative 3 volts, and V4 10 volts. So their question is find the V3 and the V5 over here. Let's still consider KVL. Look at this one. How to find the V3? V3 is in loop 1. Also in loop 2, sure. But if you start from loop 2, you can see you have two unknowns. One equation, you cannot solve it. But if you look at loop 1, in this loop, you only have one unknown voltage. So based on the KVL for loop 1, keep in mind, when we go through loop 1, when you meet positive sign, put positive sign. So that's why you have positive V2, positive V3, minus V1 equal to 0. And V2 is negative 3, V1 is 5. Replace number with a variable, then you just need to solve V3, that is 8 volts. Yeah, so you figured out V3 is 8 volts. Now you can based on which loop. Actually, you have two methods. You can base on loop 2 or loop 3. Because, see, if you based on loop 2, you know V3, V4 already, easier, not very difficult to solve V5. And also, this big loop is also fine because you know those 3 voltages already, so just need to calculate V5. Suppose we use loop 3, then still go through the loop. So start from here. So you have negative 3, positive 10, V5 we don't know, and minus 5 because of the polarity over here. You meet a negative sign, put a negative sign. So from here you can solve. If you see the negative sign, put a negative sign. So from here you can solve V5 is equal to negative 2 volts. We have an actual loop here. You can use this loop to check. Since we solved the 10 volts here, negative 2 here, and V3 is 8 volts, so that's why 10 plus V5, but the V5 itself is negative 2, and then minus V3, so minus 8 equal to 0. So that is proof. Okay, your solution is correct. In summary, when you write a KVL equation, you go through a loop. This loop, counterclockwise, clockwise, you can define any way you want. Actually, does not very matter. And then for each component, you define the polarity by yourself. This is a reference polarity. Also does not matter. For example, like V2, the real V2 is actually here high, here low. So that's why you can see the result, I mean the answer of V2 is just a negative 3 instead of positive 3. So the polarity, your reference polarity really does not matter. And when you have a reference polarity already, then you follow the loop. If your loop meets the positive sign first, then you write a positive variable. Like in this case, for example, we still go through the loop 3. So positive V2, positive V4, positive V5. But see, this loop go over here, meet the negative sign first on this component. So you write negative V1 equal to 0.